All right, so let's find this. Let's take the first two lower class limits, and I'm going to subtract them, 64.0 minus 59.0. And so the class width is 5.0, right? Good? Now, I want to find the class midpoints. How do the midpoints? You average the first and last one. So I'm going to take 59.0 plus 63.9 divided by 2, because there's two of them. And I'll get 61.45. That's the first midpoint. Now that I have the first midpoint, everybody find the second, write down the second midpoint. Find the second midpoint.
66.45.
Well, it's an easy way of finding it. It's separated from the first one by what?
5.
Why 5? That's the class width, by a class width. Does that make sense? So add 5. Add 5 again. Good? Yes. Okay. Now, the next question is this. I think I asked you guys this, right? How did you change this? So, do you guys remember last class we talked about outliers? Who remembers us talking about outliers last class? So an outlier is a number that's really far away from the rest of them, right? So you see how we have all of my data is in the first 4 pretty much? And then I have 0, 0, 0, 0, 0, 0, and then 1. This guy's way out there, really far from everybody else. So this is a classic example of when we might use an open-ended, where I might just take all of these and just combine them all into one and make it 79.0 and up and over. Does that make sense? Mm-hmm. So you kind of see what I'm talking about? Yeah. So then you might just do that, and that would have a frequency of 1. Good? Yeah?
So then would you not have to change the class width?
Then you would not have to change the class width.
Okay.
Yeah. Because that still gives you 5 classes. Now, if it was something weird, like it would end up giving me like only 4 classes, then I might have to adjust things. But yeah.
You can do that on
Yeah, I will give you that. But I thought I'd point it out. All right. So, constructing a group frequency distribution. I would say determine the class width. So here's the deal. We've had a kind of a lot of discussion about this. Remember, the book does it one way, but Jim Hannon won. We argued about this for 2 years of like, well, do you take your width, you divide by this, whatever, blah, 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 blah. But the thing at bottom line is, you want your data to be readable. The whole point of presenting data in a table is to make it understandable for somebody else. You're trying to prove a point. So we want our data, we want our class widths to be nice, good ones that people can wrap their heads around, like 5s or 10s or 20s or 100s, things like that, whenever possible. We want our data to start with, you know, a 5 or a 0, or whatever your class width. If my class width is 10, then I want my lower class limit to start with a 0. If my class width is 100, then my lower class limit should start with should be one of the hundreds. Do you guys see what I'm saying? If my class width is 5, then my lower class limit should be a 5. You know, 5, 10, 15, 20, 25, 30, one of those. That's the point that he made, and that's why he and I argued for about 2 years, and he's right. You know, it's not about, this should not be about the math, for one thing. It should be about making things understandable and readable. Right? So the book gets tied up in the math, and I get tied up in the math. But you know, common sense eventually wins out, right? Okay, so figure out what the class width should be. And again, you got to kind of look at your range of data and figure out, well, will a class width of 5 work? Will 20, 10, or 20 work? You know, kind of figure out what kind of works for your class, for your width, for your data. So if your range is like really small, like from 1 to 12, you can't do a class with a 5. Does everybody understand what I'm saying? If we're talking about siblings and it's only goes from 1 to 12, you can't do 5. So you just got to do a class with like 2 or 3 or something like that, or maybe even 1. Yeah.
I have a question about the starting point, just for clarification.
Yeah.
It says on the slide to choose the minimum data value or the convenient value in terms of making things pretty.
Right.
I noticed on the homework that it wants the minimum data value to be submitted, or I wouldn't get it correct. So what are you looking for personally on your exams in order to get the question correct on your terms?
Right. So I might need to delete that homework question.
Well, I think a lot of them were kind of like that because a lot of the frequency distributions, all of your answers kind of rely on those values that you choose, and everything else is deciphered from that.
I tried to pick homework problems that only had class widths that were like 5 or 10.
Okay.
Let me know if I screwed that up somehow. I mean, unless they were really small and they'd probably like 2 or 3, right?
Yeah, I don't think all of them were.
Okay.
I've definitely done some making them off of bar graph information and pie chart information.
Oh, yeah.
So
right.
I'm not sure, but
And even my examples, even if you look at my quiz, it had some different things, right?
Yeah.
So that's about, if you're constructing one, I want you guys to be constructing ones that kind of start with numbers that are 0s and 5s and things like that.
So for the exam, that's what you want us to do?
That is what I want for the
We
exam.
won't get it correct if we do the minimum data value?
I'll probably take off 1 point for prettiness out of it'll be, so getting the lower class limits correct is worth 4 points. I'll probably take off 1 point if you don't start it at 0 or 5.
Okay.
Yeah.
Okay, thank you.
Yeah. Just because I'm telling you now that you should do that. Okay. Great. So then, once you find kind of your lower class limit, then find all the rest of the lower class limits. Right? Don't try to find everything for the first class. Find all the lower class limits. Find that whole column. How do you find it? You what? Add? Add what, guys?
Class width.
Class width. You add a class width to find all the rest of them. Good? After you find all of your lower limits, then you can pop in and find your upper limits. And you have boundaries and then frequencies. How do you find your frequencies? You literally count how many fall in that range. And then your relative or cumulative frequencies if requested. Okay. Right, so here was my example last time. Right, I found these 2 things. I did find the width. And that's definitely, it's not big enough to do, I can't do class widths of 10. Because if I did 10, I'd only get 3.3 classes out of it. Do you guys see what I'm saying? If I take 33 and divide by 10. So then I have to go down and do 5s. And I'll have 7-ish classes. And then I found the 5 below 101, which was 100. And then you find all lower class limits. Then find all your upper class limits. All right, how do I find your comes for 105, 104? And the last one, you can get that one by just adding a class width to get to that last one. That's the easiest way to get to that last one. And then the boundaries, same concept. Actually, not concept. Here's the easiest way to find the boundaries. I have 104. I just tag a 0.5 on the end of it, and that ends up being the upper class boundary, which is the same thing as the next class's lower class boundary. Then for the next class, I take 109, tag a 5 on the end of it, a 0.5 on the end of it. And that ends up being the next class's lower class boundary too. The only thing that is maybe a little complicated is then how do I find the 99? This guy, I find him by taking 104.5 and subtracting the class width. Okay, so that's kind of the easiest way of finding that one if you want to find that more simply. Yeah, then find your frequencies, cumulative frequencies, things like that. All right, I feel like you guys hopefully are okay with this part. This was the one you guys did here. That was the answer you guys got. And remember, the whole point is that using the better class widths, this is a lot clearer than that is, right? And that's why we're doing this. This is literally the answer in the back of the textbook, which I think is atrocious, right? I mean, now I think it's atrocious. Before I thought it was, that's how it's done. It's math, right? But you know, it's just not that readable. All right, so let's take a look at your quiz problem number 3. Is everybody done with their quiz problem number 3?
Yeah.
Yes? Okay, great. So what you guys have is, you have, what is this? This is weight, 110, and you did 115, 120, 125, 130, 135, and 140, right?
Yeah.
And then you did to 114, to 119, 124, 129, 134, 139, and 144. And then what did you guys get for your I said boundaries? Okay, so again, boundaries, I would say 114.5. It's the same number you put down there. 119 is tagged a 0.5 on the end of it. Same number down there. 124.5. So this is what everybody has on theirs, I'm guessing, yes?
Yeah.
Yes.
Good. And then how do you find that last one? The easiest way is to take 114.5 and subtract the class width. So then I'd get 109.5. Kind of the simplest way. Then you guys had your frequencies. So someone who feels confident, give me the frequencies.
2, 5,
25,
4, 3,
43,
2, 2,
2, 2,
and 2, 2.
and then 2. Okay, great. Perfect. Great. Nicely done. Good group effort there. And then it was, I think we did relative frequencies. So this totals up to 20, was it? So the first one will be 2 out of 20, which is 0.1. 5 out of 20, 0.25, 0.2, 0.15, 0.1, 0.1, 0.1. Yeah? Great. And then the next one was cumulative. Cumulative frequency.
2, 7,
Yeah. 14.
16, 18,
Everyone get this? We're getting this from. We're adding all the frequencies up here. And then the last part was the midpoints. Yeah.
Yeah.
Midpoints. So you're going to take 110 and 114 divided by 2, and you should get 112.
Yeah.
And the next one, I'm just going to add a class width. 117, 122, 127, 132, 137, 142. Good? You can either average these two numbers or these two numbers. Either one, you get the same thing. Cool. All right. Good. So yes, so you can put your quiz away. And pull out your notes. Fine. So histograms. That's a graph. This is review from last class. Right? It's a graph that displays your data by making bars that are the heights are the same as the frequencies. And then along the bottom of the graph is going to be either your boundaries, or you can, if you want, you can put your class limits, either one. I think boundaries are easier because I'm lazy and I like to write less. But if you wanted to, you could put your class limits down below. Like written in here, you put your whole class limits written in there if you want as well. If you want to write bold numbers. So some people will do that where they wrote their class limits in here for each one, and when you write the class limits in, they don't touch. You do the boundaries, then you don't write both numbers, you just write the one number, and then, so this class goes from this boundary to that boundary. These are the boundaries for the class. It's lower limit and it's upper limit, and that's its frequency. So that's just a lot easier because all you have to do is write in your boundaries where they belong. Please notice that the lines go through the boundaries. It's not, the boundaries are not centered in the middle because the class goes from here to there. Does that make sense? So the boundaries are on the ends because it goes of the class. It's the beginning of the class to the end of the class. Good? All right, so that was the last thing we did last class was you guys were supposed to make a histogram of this frequency distribution. So you can do it either using boundaries or doing either using boundaries or do it using class limits, either one. Again, if you're going to use the class limits, they should not touch. If you use the boundaries, then they should touch. So go ahead and start working on that. Or finish that up. Who's finished it already? Okay, so if you've finished it already, show it to me or Andrea, and you can start your break early. We'll take a break until 10 after. Great, go ahead.